what was shown on the picture. Okay, so what did they find? The implicature conditions, mainly some, all, and lead to increased activation in the left IFG. Very similar, actually no real difference to the measurement of the adults, which means, or I mean, we can at least, I think, safely assume that children are able to compute scalar implicatures. What they also found, they found less activation in the left MFG for the mismatched one, the mismatched conditions, than the matched implicatures, which is very different from the adults, actually. What can we conclude? If children are able to compute scalar implicatures like we can suppose they can, why is it that they don't seem to prefer to use them? And I think it's also very safe to assume that it has to do with the processing of the implicature mismatch. It seems to be the case that it is cognitively more costly, maybe, and it's definitely not that they're unable to use them. Maybe it's, yeah, maybe it's just that it's too costly for them. Maybe the higher amount of effort they have to put in makes them choose the easier routes. Okay, that was basically it. Daniele, feel free to add information if you think that was under-informative in some instances. Yeah, thank you. Daniele?
Sorry, can you hear me now? Yes, sorry. I got disconnected during your talk. Oh. So I only saw the first part and the last part. But yeah, I mean, what I saw was kind of clear. So thanks for that. So yeah, what about the other people? It was, can you give me some feedback if it was clear? Do you have any question? Is there anything that you would like to ask to Manuel about the study, or was everything clear? Yeah, so do you have a picture of the brain areas again? Yeah, good. So so yeah, we haven't introduced the idea, the topic of fMRI, but the main idea is that with functional magnetic resonance, you can see which areas of the brain are particularly active for a special task, right? So what they did was to compare different conditions. So in all the conditions where you are supposed to derive an implicature, they dubbed them, I guess, implicature derivation, right? And then the implicature mismatch was when the implicature was not supported in the context, so in the typical cases of a violation of implicature. And they found these three areas basically. So one, as Manuel said, it's very close to Broca's area, right? And that was sensitive for the implicature derivation contrast, and the other one was active for the mismatch. So for arguably for cognitively comparing two different representations, right? Or some sort of decision that you have to make when you compare two different representations that have a different meaning. And they found that the area of implicature generation was active as in children as in adults, right, Manuel?
Exactly.
Whereas the other area, so this medial frontal gyrus, which was also active in other experiments for conflict monitoring or monitoring of different meanings and different representations and evaluation of different representations, that was not as active in children as it was in adults. So their conclusion is that yes, they can derive the implicature, which is also supported by all these other experiments in which for instance, the one we saw yesterday, in which they found that actually children are able to derive implicatures in certain circumstances, right? But it seems that they activate less the area that is active when you are actually judging meanings and judging the implicature compared to the whatever logical or literal interpretation, right? So actually this is a very nice so I like this study because it provides some very nice explanation as to why children sometimes fail at computing implicatures, and this explanation is actually quite coherent with what other people found. For instance, what we saw in the experiments from yesterday, that if you provide some contextual facilitation, for instance, or if you highlight the alternatives that are important to generate the implicature, or also to judge the implicature. So if you highlight the all alternative and then you you sort of make salient the contrast between the all interpretation and the some but not all interpretation, which actually exclude the all interpretation, then you facilitate this sort of task of comparing the two different representations, and then you might get more rejection, right? So yeah, are there any questions or any comments about this study, or about what we have seen the other days compared to this hypothesis, or everything is clear? Everything is makes sense? No remarks, no objections? Okay. All right. Thanks, Manuel. Oh, Mike?
Yeah.
Oh, sorry. I saw your picture, so I thought you wanted to say something.
No.
You're fine. Okay, good. So if this is clear, then I would proceed to present something. So, like I told you yesterday, I could present you something about numerals if you want to know more about this, or I could go to what I wanted to show you, which is our study on indirect implicatures with children and eye tracking. So, if please cast your vote in the chat or with the thumbs up. Is this okay if I present the stuff on indirect implicatures with children and eye tracking now? Or you prefer something on numerals? Okay, so I see a lot of thumbs up. So I'm gonna go with what I wanted to show you. Nice. That was nice ways to frame a question so that you get the answer that you want. All right. So, sorry, I have to close some windows because my computer crashed. Good. So You should see the slides now, right? Okay, so this is the last version of a presentation that I gave in London. But it's kind of the same version as I gave in other places. So this is a work in collaboration with Mike. And yeah, and it's kind of a follow-up of the experiment that I showed you already on scope ambiguity. But we used a configuration that is not supposed to be subject to scope shift, but only to indirect implicatures. Yeah, and also the mock name of this presentation was the Nerd and Hardenberg School Children Conspiracy in the Neo-Gricean Paradise. So this nice village that you see here is Nerd and Hardenberg, where we actually run the experiment, and you will see why we called it children conspiracy. So yeah, so now that you should know a lot of more things about implicatures, right? So you should have clear in mind what direct scalar implicatures are. So inferences triggered by elements like sum. So if you have a sentence like the girl ate some of the cookies, you compare it with the stronger alternatives. The girl ate all of the cookies, and then you infer that the strong alternative doesn't hold, and then you negate it, and then you get the girl ate some, but not all of the cookies, which in logical formulas, something like this. So this would be some, and this is not all, okay? But already 15 years ago, this guy here called Gennaro Chierchia, he theorized that there is another kind of implicature that can actually be derived by the use of the strong item, like by all, when it occurs in certain phrasal context, like for instance under negation. And we mentioned this already. So if you have sentences like the girl didn't eat all of the cookies, right? You might put this sentence into relationship with a logically stronger sentence, the girl didn't eat any cookie. And then you know this is logically stronger, because if the girl didn't eat any cookie, then it follows that she didn't eat all of the cookies, right? And then you deny the stronger sentence just in the usual way, and you get this meaning, which is the girl didn't eat all of the cookies, but she ate some, okay? So this is the mirror image of the classic implicature, because instead of asserting the existential and denying the universal, you deny the universal and assert the existential, okay? So it's not some but not all, but is not all but some. But it's very similar. So the idea is that Chierchia called it indirect implicature because it's not triggered directly by the scalar item, but by the interaction between the scalar item and some other operator in the sentence, like in negation, for instance. So the effect of negation is to reverse the logical relationship in the scale. So if before sum was the weaker item and all the stronger item, now all is the weaker item, not all, and not sum is the stronger item, okay? Is this clear to everyone? Okay, so the goal of this study was to investigate this question. So how are indirect implicatures computed? So now we refer to this class of implicatures as indirect implicatures. How are they processed? And what is the role of intonation in their derivation? And in adults and children, okay? Because we've seen there is a lot of interesting things going on in children that, for instance, they struggle with scalar implicatures. So, right. So the whole thing starts from the idea that I don't know. Yeah, I think we did discuss this in the very first lecture. So the idea is that from the original Gricean works, there was a sort of an approach that came out of that from his most loyal scholars like Larry Horn, Gazdar, Atlas, and Levinson back in the days before he sort of changed his mind. And they made a strong prediction. So this is known as the Neo-Gricean approach, or the Neo-Gricean current. So the prediction was that scalar implicatures are computed by default, okay? and you should not have a cost for computing the implicature, but a cost for canceling the implicature, right? And there's been a lot of studies investigating the processing cost of scalar implicatures, and a lot of studies found that actually when you do derive some but not all, you incur in processing costs, and you have a sort of a delay, right? You remember experiments like some of the elephants are mammals, where you actually know that all of the elephants are mammals. When you have to, when you object to some of the elephants are mammals and you say that it's false, you have longer reaction times. Okay, so yeah, all these experiments provide evidence that you do have a cost. There is probably a delay in accessing the strengthened meaning, but other studies actually found that sometimes you can access immediately. You can access immediately the implicature without showing this delay. Okay, so there is a lot of debate in the literature. So I'm going to give you one example of one of the experiments that I like because I made it. So we had this sort of context here, right, where we had these 4 participants. Sorry. Well, I'm going to close the window later. Where you have these 4 little characters here. So 2 boys and 2 girls. The 2 boys has different kind of objects. So this guy here had 3 paperweights, and this boy here has 2 paper clips, and this girl here has 2 paper clips, and this girl here had nothing. Okay, so they had to they heard the sentence, and they had to find which was the right boy, which was the target, so which was the right boy that the cook was looking for. Okay, and the cook uttered the sentence like, the boy has some of the paper clips. So the idea is that we use this compound name to have a prolonged time in which the interpretation is, sorry, in which there were 2 possible references for this description. So here there is a boy with some, but not all of the paper clips. And here's the boy with some, in fact, all of the paper weights. So until you hear some of the paper, if you do not derive the implicature, then then these 2 guys are 2 possible reference to this sentence. Basically, they might be 2 good targets for the sentence. But then when you hear paper clips, you know we're talking about this kind of object. Okay, so when you hear paper clips, you disambiguate to the guy who actually supports the implicature. But the idea is, if you had derived the implicature in advance, then you don't even have to wait for clips in order to know that this guy has some but not of the objects, and not this guy. Okay, so you should select this guy already. Now, what we found is that actually people with some had looks at chance between these 2 guys until they heard clips. Okay, so you see this was the onset of clips. So they were not able to use a scalar implicature in order to restrict the target identification to this guy. Okay, so they were not able to derive the scalar implicature in time. And we had the same experiment with numerals, and with numerals they were able to look at the guy with exactly 2 paper clips as soon as they heard 2. Okay, so this also showed a nice asymmetry between implicatures and numerals, where with numerals you automatically find the referent of the strong description of the strong meaning of the numeral, whereas with implicature you're not as fast, at least in this kind of context. And there is some debate why people do so. In other experiments they didn't, maybe because we mix numeral and scalar items. We don't know yet. All right, so we might be groping in the dark with scalar implicatures. There's a lot of hypotheses and a lot of alternative theories, but if there is one thing that seemed to be clear from the literature, is that the prediction of Neo-Griceans was wrong. Okay, that is not true that we compute implicature by default, and that is not true that there is a cost for canceling the implicature. If there is a cost, it's actually for deriving the implicatures. When we do so when we do not derive the implicature, we are actually fine. When we do derive the implicature, we have an additional cost. Okay, so again, think about some elephants are mammals. When you accept the logical meaning of this sentence, you're fine, and you have faster reaction times. When you do derive the implicature and you reject it, then you are slower. And the same as with the thing. So if you had derived the implicature costly immediately by default, you would have disambiguated this sentence before hearing this. Okay, is this clear to everyone? This kind of idea that the neo-Gricean view was not right. Okay. So now we are also expert in acquisition of implicatures. So that's great. I don't have to explain these things anymore because you know this better than me, right? So we've seen a lot of experiments exploring the option of why children are so bad at deriving scalar implicature. And there is, the initial hypothesis was that they did not have the pragmatic competence. So, right, the kind of hypothesis Emmanuel was discussing. So children are not able to derive implicatures because they don't have enough computational resources, because they are not competent pragmatically, because they cannot retrieve the alternatives, and all these reasons. There was hypothesized that they have some problems at the derivation of these inferences, whereas in later studies, like for instance the one we've seen together, and the one that also some people will present in the next days, see Katsas and Bishop, Papafragu and Musolino, Papafragu and Tantalu. I think we actually, I think we've seen this study, right? So so the idea is that actually children, if you give them the right contextual setup, if you make pragmatically salient the role of alternatives and so on, and if you highlight the contrast between all and some, for instance, they can actually derive implicatures, and they get close to adults' performance. And you remember ternary and binary judgment and all these kind of things. So the idea is that, just as we saw in this study, the problem is not localized at the level of the derivation of the implicator itself or the retrieval of the right alternative, but at the level of the evaluation and the repair or the reanalysis due to a mismatch between the scalar implicature and what the context shows, okay? So, there's been a kind of a shift in the paradigm, suggesting that actually children are able to derive implicatures from the very early stages, okay? So this should be kind of clear now. Good. So now let's move to this curious case of the indirect scalar implicatures, right? And let's wonder, how should they be processed given what we know about processing in children and processing implicatures? And the idea is that they should be quite bad, actually, because first of all, they include negation, and we know negation adds a processing cost. It always makes things more difficult. And also, if you have this kind of not all thing, it's not a lexically defined scale, right? You remember we had some discussion about how the elements of a horn scale have to be composed in order to enter a horn scale, and that you are constrained in building up your horn scale. You cannot just put any element you want. They must be equally lexicalized. They must belong to the same semantic family, and yada yada yada. So not all is already problematic by itself, because it's not it's not semantically simple. It's not one word. It's actually composed by two words which occur in different positions of the sentence. Right. So how should these not all inferences computed? Not all, but some. Well, if scalar implicatures are costly, then indirect scalar implicature should be costly, right? And if scalar implicators are not computed by default, indirect scalar implicator should not be computed by default. And if children struggle with scalar implicature, with direct scalar implicature, they should struggle even more with these guys, because then you also have negation, and you also have this kind of scope configuration to compute, and you have to compose negation with the universal quantifier in order to activate the scale and to derive the implicator. All right. In fact, in some previous experiments that have been done, some evidence has been found that actually people are not so bad at computing these indirect implicatures. So Musolino and Leeds, in one of their experiments, found that actually children tolerated the violation of these inferences in this context where they had the sentence like, the frog didn't eat all the flies, in a situation in which the frog did not eat any fly at all, okay? So again, implicature violation, the adults rejected it and the children were fine with it, showing that this kind of tolerance of violation behavior, okay? Just like as with scalar implicature, as with direct scalar implicature. But other experiments, like this experiment by Corey Bill, found that actually indirect scalar implicature boosts comprehension in children compared to direct scalar implicature. So they found some evidence that their children are not so bad with these inferences. And also there is this study by Kremers and Schemla finding that it seems that in adults, indirect scalar implicature in a way provide a facilitation in reaction times compared to direct scalar implicature. So some clues that for some reason people are not so bad at processing and deriving these inferences, okay? And if you remember, in the experiment that we discussed by me and Carolina Loginiva, we found that with these every pirate didn't go back to the ship sentences, children were actually better in the inverse scope condition. So with not every pirate went back to the ship, which, guess what, give rise to an indirect scalar implicature. So not every pirate went back to the ship, but some of them did. And we put forward this pragmatic boost hypothesis that it was a derivation of a scalar implicature that facilitated the comprehension of inverse scope, because inverse scope by the not all interpretation would be logically compatible with the non scenario, but then if you derive the implicature, it's not compatible with that scenario anymore, and then you can have some specific effect for the not all but some scenario. Okay, so again, strange results and some hints that actually both children and adults might be actually good with indirect scalar implicatures. Okay, so maybe this is the right time to take a 5 minutes break, so then we can go with the experiment. What do you think? Do you agree? Okay, so let's meet in 5-ish minutes. All right, so yeah, so here's the first experiment that we did. So it was a semantic choice task. So it's a picture selection task with eye movement recording. So it's very similar to the other experiment that I showed you a few days ago. So yes, so the idea is that you can get offline judgments, right? So it's similar to a true value judgment task, but the difference is that you don't have to evaluate just one picture, but two pictures at the same time. And this gives us some advantages that we are gonna discuss in a few minutes. So yeah, so the idea is that you can test for the access to a specific interpretation or to the preference between two different scenarios. And also you get the online tracking data, which gives you information about when the disambiguation takes place, right? So what is exactly the time at which participants manage to disambiguate the scenario, as we've seen with the SAM experiment, with the sum of the paper clips, but also how different readings are processed. So if you are faster at processing one kind of reading or the other one, or at disambiguating one scenario or the other one. And in this experiment, we use this sentence. So, der Kapitän hat nicht mit allen Meerjungfrauen getanzt. So the captain has not with all the mermaids dance. So the captain did not dance with all the mermaids. And we use this prepositional phrase with not to have nicht and allen occurring one after the other, okay? In order to be sure that they would not interpret not all as a single quantifier, okay? Right, so the other thing we did was to record these sentences with what we called an unbiased intonation. So we did not put the normal intonation for this kind of sentences, and then we're gonna see how that sounds like. But we had this kind of very, very kind of flat intonation where we only put a very, very small stress on Kapitän and Getanz. No, sorry, Kapitän and Meerjungfrauen. So we did not put stress on nicht or allen, where you would normally put your intonation with this kind of sentence. But we had this kind of the Kapitän had nicht mit allen Meerjungfrauen getan. Okay? In order not to bias participants' response. So we wanted to have a sort of a baseline experiment, okay? Right, so here's an example of an item. So you have the, the red pirates on your left and the green pirates on your right. They meet the mermaids that were having a party in a swimming pool, okay, inside a volcano. So the pirates found the mermaids who were having, a swimming pool party inside the volcano. So you could see in the stop motion the mermaids dancing. And then the red captain, this guy here, joined the party and danced with 4 mermaids in the warm water, while his friends were dancing by themselves. So this guy here. Whereas the green captain, this guy here, he danced with a pirate out of the volcano, while the other pirates danced with the mermaid, okay? And then they were asked to pay attention to the following sentence. The captain did not dance with all the mermaids, okay? So, is this sentence true in this kind of scenario? Yes or no? Can anyone answer?
I want to say yes. It's true.
It is true that the captain did not dance with all of the mermaids here.
I'm not. That's not my native language. But when I hear a sentence like this in German, I want to always like continue with saying like sondern. Like it means like to put some more information. Whom did the captain dance with? Like nicht mit, not with all mermaids, but with all the crabs, for example. I don't know.
Right, but here he is dancing with all the mermaids, right? In this picture here, in this context,
Yeah.
he is dancing with the 4 mermaids, okay?
Yeah.
And the sentence is, the Kapitän hat nicht mit allen Meerjungfrauen getanzt. So the captain did not dance with all the mermaids, okay?
Yeah.
So I'm asking you if this sentence is true in this context.
Oh well, no.
Okay, right? Because he is dancing with all of the mermaids.
Yeah.
Okay. And now the question is this sentence true in this context where he is dancing with no mermaid at all? If I tell you that the captain did not dance with all of the mermaids, and in fact, he's dancing with the pirate friend and no mermaid at all. Is this true or not?
I think it's true.
Right? So it's ambiguous, right? So it's the usual problem that we've been facing in all these days. If you compute the implicature, you would say it is not true, right? If you compute the implicature and you interpret the sentence as the captain didn't dance with all the mermaids, but with some of them, then this is not true. But if you do not compute the implicature, or if you cancel it, right? and you interpret this as the captain didn't dance with all the mermaids and maybe with none, then as you said, this is true. Okay? Is this clear to everyone? Do you see the problem? Okay, good. So yes, so thanks Gergana for being our participant today. So this represents the implicature violation condition, right? Yeah, and at the end they had to answer this question, like who did better, right? Choose a group of pirates which perform better, given the sentence you just heard, or reject both if they both perform badly, okay? And to reject both, you had to look at this picture and press a button, okay? Right, so this condition that I showed you was the access to the indirect scalar implicature violation, or the violation of the scalar implicature, of the indirect scalar implicature. Because again, in order to select this context, you have to cancel or suppress a scalar implicature, okay? But how about this context here? If I tell you the captain didn't dance with all of the mermaids, and he is dancing with just two of them, would this sentence be true? Gergana, can I ask you, since you are our today's subject?
Oh yeah, what did I put myself into?
Would you accept this picture as a description of this sentence?
Did not dance with all the mermaids, but well, no, because well, actually yes, because not with all, but with some. So
Good.
those are the some he danced with, and the others with whom he didn't dance are, yeah.
Okay, very good. So this is a context that does support the implicature, right?
Yes.
And so, but even if you do not derive the implicature, even if you interpret this sentence as not all and maybe none, it would still be compatible with this context, right?
Yeah.
So ideally, you know, there's no way why you should not accept this context, basically. So this condition is compatible with both readings, whereas this condition is not compatible with implicature, okay? Okay, and then as a last condition, we had this preference condition where we actually put the two possibly true contexts, one next to the other, right? So here, if you do derive the implicature, then you should prefer the null context, so the context where the captain is dancing with not all but some. But if you do not derive the implicature, then both contexts are fine with you, okay? Then you could either choose this context or this context. So you could, you know, you could choose any of them. So this is a further test, not only to test if you have a strong preference for the implicature, but also if you have a preference for one of these two contexts in general. Okay? Good. So, right. So the whole experiment was composed by 16 trials. So 4 trials were in the access to the non-condition, implicature violation. 4 trials were the access to the null condition, implicature support. 4 trials were preference. And then we had 4 trials with controls without negation, okay? So like all the, the parrots ate all the strawberries or something like this. The whole experiment was lasting about 30-40 minutes. And we had 48 German speakers from 6 to 10 years of age and adult controls, okay? And the task, you've seen it. Right, so what do we expect? So if these kind of implicatures boost comprehension, as some other experiment found, we would actually expect a facilitation effect for the null context, for the implicature support context, okay? And people should be more accurate there than the non-context. So if the implicature helps you identifying the correct context, then you should be better with the implicature support condition. And however, if these implicatures are costly, you should be slower at identifying the right context in this implicature support condition. And then if children struggle with implicatures, then you should have this effect that the comprehension of these sentences increases with age, right? Whereas if indirect scalar implicature facilitate comprehension in children, you should have a boost effect for the implicature support context, as we found in the previous experiment, okay? So we have some kind of competing hypotheses. We don't know whether the indirect scalar implicature is going to be computed or not by children, and we don't know if it's going to facilitate in the comprehension or slow down their rate of disambiguation, their pace in disambiguating the scenario, okay? All right, so what did we find? So these are the offline results. So the rate of choosing the right context or the wrong context or rejecting both, okay? And you see that they actually had a higher accuracy. They displayed a higher accuracy in the null context compared to the non-context, okay? So the adults accepted the true context more often in the implicature support condition compared to the implicature violation condition, where they actually rejected in 28% of time. In 28% of times, they said, I don't like any of the two contexts, okay? And they selected the wrong context very, 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 very rarely. So they made very few mistakes. What about the children? Very, very similar results. So the children as well preferred the context compatible with the indirect implicature. In 84% of time, they had fewer rejections, okay? So it seems that they were more tolerant, especially in this context, to implicature violation. And also they accepted the implicature violation context less often. So more accurate, high accuracy in both conditions, but more accurate and less rejection in the implicature support, which suggests that the children were sensitive to this indirect scalar implicature. Now, what about the preference when they had to prefer one of the two contexts when they saw them at the same time? The adults show a quite strong preference for the null context supporting the implicatures, so 77%, whereas the children displayed a milder preference for the implicature support context, which increases with age. So 8-year-old, 8 to 10, had a 68% for the implicature context, for the implicature support. So kind of similar to adults. But if you move to younger children, they show a much smaller preference, if any, okay? So this is reminiscent of the tolerance effect for the implicature violation. The younger they are, the more tolerant for implicature violations are, okay? Any question at this point? Is there anything you would like me to explain better, or it's clear? If it's clear, raise your thumb. Otherwise, please make some noise. Okay. So I'm gonna go on. Right. So now we're gonna look at the online data, okay? So again, we are interested in this sort of index called target preference. So let's say that this is your monitor and you are looking at this at two contexts, okay? So you hear the story of this context, and then you have the final picture, and then you have to decide whether you want to pick the context on the left, which in this case, for instance, was false because the captain danced with all the mermaids, or one of the contexts on the right. So in one trial, you might have the implicature violation context when the captain danced with his friend, and in another trial, the implicature support where the captain danced with not all, but some of the mermaids, So you only would see one of these, okay? And what we are interested in is the time at which you develop a preference for the true context, okay? So the time in which you realize that this context is actually bad, is actually a bad description, that the sentence is a bad description for this context, and that the sentence is false in this context, but it's true in this one. And that in the eye movements is reflected in a departure of this target preference line, which tells you how your looks are more systematic on this side of the screen, so on this context, on the target context, compared to this other one, okay? So you are interested in when the target preference departs from chance and when your target preference line raises towards 100% from 50%, okay? And then we can compare this in these two different conditions to see in which one condition you're faster at identifying the right context. So what happened? So here's the children. This is the onset of nicht, okay? So what was the sentence again? The captain did not dance with all the mermaids, so did not dance, and then you still had to hear all the mermaids, okay? And what you see is that so the green line would be implicature support, null condition, and the orange line, implicature violation, none condition, okay? And what you see is that after kind of a second and a half from what you hear nicht and what you actually, when you actually hear all, you sort of figure out that one of the two contexts is actually a true one. So quite early, you developed a preference for the null or for the non-context. And this actually, this goes in a way towards a better performance for the null context. So you are faster in the context that supports the indirect implicature compared to the context that violates the implicature, okay? And we are talking about children here. So you see the green line here is above the orange line, which shows that here your looks are more steady. You are less indecisive as to which of the two contexts is the right one, which means you are faster at disambiguating the context supporting the implicature rather than the context violating the implicature, okay? Now, if you compare this to what the adults did, what do you see? You see that actually the children were faster. The children were faster at disambiguating both contexts, so both the null and the non-context compared to the adults, because you see they kind of show some kind of early disambiguation here, but then they go back to chance, and then they sort of go back to disambiguating the context, okay? But more interestingly, the difference between the two conditions only popped up at about 4 seconds. Very, very, very late in time. So 4 seconds after you hear nicht, so almost at the very end of the sentence. Whereas here in the children, you see this difference very early, already at 2 seconds from the onset of the sentence, okay? So what it shows is that you had an early disambiguation in children compared to adults, which is quite surprising because we know that adults are faster, they have more working memory, they have a better processing skills, and as we've seen before, they're also better at comparing different representations, so they have better monitoring and better conflict monitoring resolution. So what the hell is going on? So if you just take the critical null condition, the implicature support condition, and you plot the target preference of children versus adults, you see that there is a strong effect at 2 seconds for which children already disambiguated the context, but adults didn't, okay? You see this big difference between adults, which are the dotted dark green line, and children, the solid light green line. This shows that at 2 seconds from the onset of NICT, more or less right after the onset of ALE, children already went for the right context, whereas adults didn't. Okay? So again, earlier disambiguation in children. That's quite strange, right? So sum up, high accuracy in both children and adults, and less tolerance to violation in adults. Yet, a processing advantage for the context supporting the indirect scalar implicature for the not all but some context compared to the context violating the implicature. So I call this with a mocking name the Neo-Gricean paradise, okay? And we will see why, but the reason should be kind of clear, because this supports the hypothesis of the Neo-Gricean that you have an immediate computation of the implicature, that you compute it by default, and then if anything, you cancel it in a context that does not support the implicature. And also this kind of school children conspiracy whereby the children were faster than adults, okay? Where you have the more rapid identification in children than adults. Very strange. So the question is, why are children faster than adults? What was going on? And probably to answer this question, we really have to investigate the question of what the role of intonation is, right? Is there is something weird or strange that we did in this sentence was to use what we call an unbiased intonation, but actually this unbiased intonation might have to do something weird. Like for instance, a non-natural intonation might have triggered some other inferences in the adults that are not really supported by this context. Like, you know, if you put if they interpret this sentence with, like, for instance, topicalization on the captain, so like the captain didn't dance with all the mermaids, that would suggest that someone else danced with all the mermaids. Okay, this sounds a little bit like the every horse jumped over the log, but every horse didn't jump over the fence. Okay, so you set up some contrast in your mind, and then you look for a reference to this contrast. You don't find anyone in the visual scenario, and then you're like, what the hell is going on? Or both groups pay attention to intonation, but adults, for some reason, children don't pay too much attention to intonation cues, whereas adults cannot ignore intonation. So if you provide an intonation which is not completely consistent with the sentence, then adults struggle more because they cannot inhibit that. Whereas children, although they actually are sensitive to intonation, they're more sort of able to don't consider the intonation if that does not support, if that is not consistent and coherent with the interpretation of the sentence. Okay. But as far as we know, maybe children do not even pay a lot of attention to intonation. So maybe they do not consider intonation at all. Okay. So what we did was to run another experiment, the experiment 2, where we actually used a natural intonation for sentences generating indirect scalar implicature. So this time we put stress on the quantifier, and we de-stress the second part of the sentence. Like, the captain didn't eat all of the cake. The captain didn't dance with all of the mermaids. Die Kapitän haben nicht mit alle Meerjungfrauen getanzt. So you have the stress on alle and then the de-stressing of the last part, okay? And we also recorded sentences a little bit more naturally. So they were very slow in the first experiment. So we record them a little bit more with a faster pace to make them more natural, because we thought that maybe adults were freaking out because of the very slow pace of the sentence, okay? Now the next, when I'm going to present you another study, I'm going to also play these sentences for you, so then you have a feeling of how these sentences sounded. Okay. Right. So prediction for the new experiment. Now that we have actually a more felicitous task for the adults, because the sentences are more natural, the adults should be faster. So they should be as fast as children, if not faster. And we should even get a stronger preference for the scalar implicature violation, okay? And less tolerance. Sorry, a stronger preference for the indirect scalar implicature support and less tolerance for the violation. So we should strengthen the preference for the context support in the indirect scalar implicature. And let's see what happened. So let's look at the choices first. In the adults, you see that in the context that supports the implicature, they actually had a few less rejections and a little more acceptance. In the context that did not support the implicatures, they had more rejection. So 11% less of acceptance rate for the non-context. And this is good, because this tells us that actually the manipulation of the intonation has an effect, okay? As for the preference, in the preference context, there was a slight increase of the preference for the null condition. So again, good news, not a very big effect though, okay? So you see only 5% here, 8% here. So it was working, but we're not sure if it was working a lot, just by relying on the offline judgment. Okay, what about the children? So now we only have 36 out of 48 children. So we still need to run a few more children, right? But still you see some clear pattern, like for instance, again, more rejections and less acceptance for the violation. So they also made a little bit more errors, but because we did not do any outlier rejection here. So probably when we have more children, this is going to be completely comparable to this experiment. So that's why you see a little bit of decrease here in the acceptance rates, because you got more errors, but you see in this condition that there is a clear trend in accepting this condition less. And in the preference, big increase in the preference for the implicature support. So on average, it went from 72% of choosing null versus none to 75%, okay? So also in children, the manipulation of the intonation works, which suggests that children are sensitive to intonation, okay? Now let's look at the online data, and let's look at the adults first. And finally, we found a much nicer profile. So again, we are comparing implicature support versus implicature violation, right? And now in the adults, you see a very, very nice, neat effect. What you see is that after nicht, there is a small preference for both known and null scenarios, so for both implicature support and implicature violation compared to the false scenario, right? So this line increases and departs from chance, but then at about 1.6 seconds, in the implicature support, this line keeps on increasing, but in implicature violation, it goes down, okay? So in the implicature violation, at some point, you go back and you look at the picture with where actually the captain danced with all the mermaids. So you are still undecided as to which one of the two pictures, which one of the two contexts is the right one, okay? And then after a couple of seconds, you make up your mind again and you look again to the right picture, okay? So this is a little bit what Gergana did when she was like, I don't know, maybe this is right or maybe this is wrong. So I'm gonna go back to look at this one, okay? So very nice effect. And yeah, So when the indirect implicature is violated in the non-condition, the looks to the target decrease, and you have again uncertainty. And if you compare just the adults between different experiment 1 and experiment 2, because you remember in experiment 2 the sentences are a little bit faster, so you cannot compare directly. You have to be careful comparing directly the stream of the looks. So here we just averaged the proportion of looks to the target in time windows, like for instance, when they hear the object or the PP, or right after the end of the sentence. And you see that in the experiment 2, there is a difference between the condition supporting the implicature and the condition not supporting the implicature, significant already at the PP region, and it's kind of larger in the previous regions too, okay? So greater difference between conditions in experiment 2 than 1 in adults, in earlier time windows. Now, what about children? So you remember children were quite good already in the first experiment, but they show a very, very big effect in the second experiment. In fact, bigger. So again, this is implicature support. You see that they disambiguate the scenario at about 1.5 seconds, but in an implicature violation, they keep on being a chance. They have a little bit of a disambiguation here, right? So maybe some subjects, some participants in some trials, then they are still a chance, and then again, there is a second time in which there is a little bit of disambiguation, and maybe they provided the response after this time, okay? So again, big processing advantage for the implicature support, which again suggests they did derive the implicature. And if you compare now children and adults in the implicature support condition, they are actually very, very similar. And if anything, there is an advantage for adults at 3 seconds. So quite late advantage for adults, okay? Which is good, which is what we expected from the very beginning. Right. And also if you compare the non-condition, you kind of find the same pattern. So there is a late advantage in adults. So to conclude, you see that the role of intonation had a small effect in the offline judgments, but a big effect in the online data, especially in terms of a huge improvement in the online disambiguation pace in the adults and in the decrease of their uncertainty. So we kind of managed to turn adults into children with respect to the first experiment. So the difference between children and adults is smaller, and there is no more advantage for children. So the North and Southern Bank School children conspiracy in a way has been investigated and addressed. And still there is this systematic difference between a context supporting scalar indirect scalar implicature and the context violating them in both adults and children. So it seems that the not all but some is the first available representation of the sentence as soon as all is combined with negation, okay? So that's again strong evidence for what I call the Neo-Gricean paradise. So these very, very predictions that the Neo-Gricean approach made that implicatures are computed by default, and that these predictions were never borne out, it was never found evidence supporting these predictions in all the experiments with the direct scalar implicatures, right? So we are finding evidence for this with the indirect scalar implicatures. Strange. Right, so first of all, we might ask ourselves, why do adults require supporting intonation, right? And we can rule out the hypothesis that adults pay more attention to intonation than children, because in fact children paid a lot of attention to intonation, and they used the more supporting intonation to in their online resolution and also in the offline choices, because they showed a much, much greater effect in favor of implicature support. So yes, children do pay attention to intonation, right? Both groups pay attention to intonation. So maybe one of these two hypotheses is true. So either children are able to only use intonation when it's supporting their online interpretation of the sentence, or maybe adults cannot ignore deviant intonational cues that maybe let them derive other inferences like topicalization that is not really supported in these scenarios, okay? And we don't know for sure. Right. So maybe there are alternative explanations to this, okay? Maybe, you might always think about other ways to interpret your results and not be biased to the way you prefer. So maybe, the null contexts are generally easier to process than the non-context, okay? Maybe this effect we found for processing advantage for implicature support, maybe it's just due to the fact that when you process a context where there is the target doing something, like dancing with two of the mermaids, right? Maybe this is easier to process than when the captain is not doing anything of what was said in the sentence. So if in the sentence you're talking about dancing with mermaids, but then in the context you're dancing with your with your pirate friend, that creates a mismatch automatically, which induces sort of a delay in processing, okay? So why is this alternative explanation not really supported by experimental data? Because if you remember, in the previous experiment of scope ambiguity that I showed, which involved the very same paradigm, we actually found that our participants was faster at disambiguating the non-scenario. So you see there, you had a processing advantage for the condition in which no pirates went back to the ship, okay? So here, again, all the pirates did not go back to the ship. This condition represents a universal negative. The one in no one of them did what was mentioned in the sentence. Whereas here, you had that some of the pirates went back to the ship and some didn't. So not all of them went back to the ship, but some did. So inverse scope, support for the indirect implicature. And here, this context was actually more delayed or more difficult to process, okay? So here you had a processing advantage for the non-context, so exactly the opposite pattern. So this suggests that it's not the property of the context that makes things easier. It's really the way you interpret the sentence. Okay, so what about, right. So what about the preference condition? I haven't told you a lot about the preference condition in the online data. So I just want to show you just briefly what happened, and then we can talk about that together. So, this is a target preference analysis where we only included the trials in which the participant chose the null context, okay? So if you remember, in the preference condition, which we dub neg here, so this would be the blue line, you have to choose not between a false scenario and the true scenario, but between the two possibly true scenarios. So one supporting the implicature and one not supporting the implicature. And then we said, okay, let's only keep the trials where actually people chose the null context. So let's only keep the trials where they chose the implicator support, And let's compare those trials with the unambiguous condition where the implicature support was compared to a false scenario, okay? So null context compared to none, and choice for null context versus null context compared to false, which would be all scenario, and then choice for the null context, okay? And let's see what happens. And what happens is that there is a comparable Bayesian disambiguation, but still you have this sort of processing advantage for the implicature support in the unambiguous context. So this shows you that even when you make the same choice, even when you have a preference for the implicature support, the presence of the non-alternative is not helping you. In fact, it's sort of creating a sort of a referential ambiguity that's going to have this effect of slowing down your reference resolution, okay? So yeah, so this is an interesting effect. Okay, I'm going to skip this and get to the end, okay? So you see, this is kind of puzzling, right? So in all the studies that we reviewed, it was said that there was evidence that direct implicatures are not computed by default, and they have a processing, and they incur into a processing cost, whereas indirect scalar implicatures in this experiment seem to be computed by default, okay, and very, very, very fast and very automatically. Why is it the case? So we don't really know, right? But if we speculate a little bit about this, if you look at how direct scalar implicature computation works, what happens is that you have your scalar trigger, which is like represented as an existential quantifier here. So this would be sum. The girl ate some of the cookies. So this logically means there is at least a cookie that the girl ate. Then you activate your all, represented by universal quantifier. So the girl ate all of the cookies. You deny your stronger alternative, and you're left with this one. So in order to compute the direct scalar implicature, you need to activate this, right? Now look at the alternatives for indirect implicatures. Basically, if you have a not all, you might represent the stronger alternative just by using the same elements that you have in the original sentence, which are negation and universal quantifier. All that you have to do is to switch the order of these elements. So in a way, to sort of perform an operation of scope shift, but in a sentence where you actually do not do that. So basically, logically speaking, the alternative for not all not, is a universal negative. So, you know, one speculation is that maybe within direct scalar implicature, your alternatives are always active because they are included in the sentence. Whereas with the indirect scalar implicature, with the direct scalar implicature, you have to retrieve the strong alternative from the lexicon. And maybe this is one of the reasons why indirect scalar implicature are surprisingly so robust compute, okay? So again, if this is true, this has to be done at some abstract level of the logic form, because as we said many times, for instance, if you literally substitute sum to all, so if you have a sentence like the captain didn't dance with some of the mermaids, right? The natural way to interpret this sentence is by scoping out sum, because sum is a positive polarity item. So you usually do not interpret it within negation, right? So you scope out some, and then some is not a good alternative anymore. Then you can use any. So you can say, okay, my right alternative is any, right? But then you don't have a parallel to the same Horn scale that you would use with the positive implicator. So in one case you have some but not all, and in the other one you would have not all but not any, right? So you see, it's not a parallel derivation. Or you do this, but you do this at the logical level, because at the overt level you do not have scope shift with these kind of sentences, right? This is what we saw in the very first classes. So who knows? Right. Yeah. So this was my my group, and yeah, and thank you for the attention. Right. So was this clear? Thanks for the claps. Was this clear? Was this nice? Did I convince you about the, you know, the fact that this kind of data is interesting because it's not what we would predict, right? And it kind of goes against what we have seen in the other experiment. Any question, any comment, any thought, anything? Don't be shy. If you have some remarks or something to ask. If you're tired, I would really like you to come up with some comments or questions on this topic for the next time, okay? So please think about some critiques to this experiment, or some, you know, comparison to this and the other stuff that we have seen before, and prepare some question for the next time, okay?
Would you mind maybe
the last thing that I wanted to say, right. So one last thing that I wanted to say. So this final speculation that indirect scalar implicatures are actually computed by default and more robust than scalar implicature is just a speculation, right? And it's not really, I mean, we cannot be sure in concluding this because we haven't tested the direct scalar implicature with this paradigm, okay? So we don't really know if it is really indirect scalar implicature to be so strong, to be so robust, or maybe it was our paradigm that make them so strong. And maybe if we test the direct scalar implicature with the same paradigm, we are going to find the same result, okay? So in order to conclude that indirect scalar implicature are more robust, are more computed by default, are more automatically computed than direct scalar implicature, we need to compare the two classes of phenomena with the same experiment, with the same experimental design. And that's actually what we did, and what I'm going to show you either next time or in the last lecture, okay? Okay. I guess this is it for today. So we meet tomorrow, this time at 12:30, so 12:30. Okay? Please think about some questions for me, and have a nice day. Bye, everyone.